Roll number 191016. Today I will discuss about the project that was given to us of Zumo line follower robot. So first of all, what is a Zumo line follower robot? These robots are designed specifically to follow the line or the path that is already being fixed by the user or by someone. It means that it can be predetermined or can be controlled drastically. The path selected may be straightforward as a visible black line on the ground or a chart or whatever, as compared or a arena, as compared or as complex path marking plots, for example embedded lines or permanent markers to detect the lines on which our robot will be moving. Different type of sensors and different type of sensors are used which sense the line from the surface and give us some value, and then different algorithms or procedures are applied to make the robot move on that line. The line following robot is a system that has some intelligence, so it has ability to decide on its own, so the robot itself position himself as it powers up on the black or white line. In general, a robot's incomes, or you can say inputs, are voltages of the circuits, and sensor voltages variations are variations. The robot processor is basically a microcontroller. The main processor from which it gets power, current or voltage is basically a microcontroller. In this case we will use an Arduino Mega 2560. In this project we are using Arduino ATMEGA 2560, which reads the signal coming from IR sensors, and which it compares their values, and based on that logic that we used in the robot will send signal to the motor driver, the voltage signal to the motor driver after reading the values from sensor to make the robot work, because the robot will work on the basis of the motors that are running the wheels. Now motor driver will drive the wheels of the robot, so our robot will stay on the track according to the information or the code that our microcontroller will be processing and reading through the sensors. The major characteristic of the robot is to contrast the last ones in this field, and it includes increase in the maneuver capacity with unexpected changes of points. This robot can be used for carrying stuff of informations between two special points. For example, a transmitter or receiver. You saw it like two rooms in an office, two rooms in an office or in a hospital. Can be used in hotels as serving foods and etc. for carrying luggages and all those stuff, goods, etc. Now it contains some list of features, which are that the specifications or the personal specification that we did on our own in this project are: the robot is able to make turns in every direction and make its decisions accordingly. The robot is able to make a complete turn when it reaches endpoint. Data logging is done using SD card module, LCD to display all the data and voltage or current measurements, SD card the distance it has followed, and through encoder and SD card we can measure that as well and display it on our 16x2 alphanumeric LCD. And you can see the block diagram. This is for 3 sensors. We have used 5 or 6 sensors, and cell or a voltage source is attached to the motor driver. The pins of the motor driver, VSS and VCC. VSS is given 12 volt, VCC is given 5 volt, and at least minimum 2.5 or 2 ampere, and 3 ampere is more suitable. Left motor, right motor, or motor 1 or motor 2 is attached to the output of the L298 motor driver, and the L298 motor driver is basically attached to our ATMEGA or Arduino Mega 2560. An LCD is attached, voltage sensor, current sensor, SD card module, 6 or 5 IN sensor, QTR sensor you can say, is attached to the pins of pins that are specifically designed or designated to the ATMEGA 2560 or Arduino Mega. So here's the data sheet of the different components that we used. This is IR sensor. From this you can see that the distance adjustment, it senses that some obstacle or the path it is following. From this you can increase or decrease the sensitivity of IR sensor from distance adjust. This is a power LED and there are 3 pins, one of VCC, one of ground and one of output. This is obstacle LED and one IR receiver and one IR emitter or transmitter or receiver is used inside the IR sensor. The VCC should be given up to 3.3 to 5 volt DC supply input, ground input, output that goes low when obstacle is in range. Power LED illuminates when power is applied. Obstacle LED illuminates when obstacle is detected. Distance adjust detection distance. Counterclockwise decreases distance. Clockwise increases distance. IR emitter, infrared emitter LED, and IR receiver, infrared receiver that receives signal transmitted by infrared emitter. Ultrasonic sensor to sense the object that is coming in the path that is being followed by our line following robot. And there are 4 pins, one of VCC and ground, and there is a trigger and echo pin. It is HCSR04 and the pin function description is somehow the VCC and ground are the same. In trigger pin there is a trigger pin that is connected to the pins of the Arduino ATMEGA, and echo pin is the receiver pin. So this is our Arduino Mega and these are our pins for that, and inside that we have some ports, and these ports are designed for some purposes. For example, here you can connect the SD card module, which has I think 4 essential pins that are SCK, MISO, MOSI and CS, and analog pins for the encoders that convert the analog information or the analog signals into digital information and show it on our LCD. And for some ports are for our voltage sensor or the current sensor, and basically these will be connected on our analog pins, and some PWM pins that are reserved for the driver for the motor driver to control the speed or the RPM, revolution per minute, of the motors of the line following robot. A VCC and ground is also there, so you can see that. First of all, we can see you will see in the video further that we used a 4-wheel base, and the base of the wheel is made of acrylic base with 2 gear motors, or 4 you can see is say 4 because of you can just mount it into 2 motors into one function mounted on it. 2 compatible wheels are attached with the motors and a ball caster, or another 2 wheel set is attached with the base in front of it. The package contains following accessories: 4 rubber wheels for DC motors, 4 aluminum fasteners as I told you, 1 nylon wheel you can use it or not, 1 chassis of acrylic material, and a battery box. DC motor specification, that the servo motors or the DC motor that we used is that the voltage should be given from up to 3 to 6 volt. Speed is maintained as 120 rpm. Sorry. Current of 190 milliampere up to 250 milliampere. or you can say that 1.9 ampere up to 2.5 ampere. Maximum torque is 800 Newton. Chassis specification is dimensions are 19.6 centimeter into 10.5 centimeter into 0.3 centimeter. Weight is 14.29 Oz. Wheel specification: width 30 meter, diameter 65 millimeter. Width is 30 millimeter. Now we will talk about that how that sensor behaves. The line follower robot that we made is using IR sensor to sense the line. The three different modules of infrared sensor. In this case, 6 different modules of infrared sensors are mounted in the form of the robot. In front of the robot, IR sensor module made up of 2 diodes that one of them sends infrared rays and receiver receive these rays as they are deflected by the surface to detect that whether there is some obstacle or not. Yeah. So I was talking about the sensor working, the behavior of the sensor, and these infrared radiations, which are not visible to the naked eye, cast the surface in front of receiver LED of the sensor. Surface bounce backs the infrared radiations. Now the reflection of these radiations depends on the ability of reflectivity of the surface on which our robot, the line follower robot, is moving, and the amount of light varies every time. These bounced back radiations made incident on reverse bias of the infrared sensor. When these photons are being experienced by reverse bias junction of infrared sensor diode, a little amount of electron hole pairs are initiated, due to which it results in the reverse current. This current is passed through a resistor in order to get proportional voltage. The voltage across the resistor will keep on changing as the amount of infrared rays vary. If the receiver of the infrared sensor receives the reflected rays, so it means that our robot is on white surface, and if the sensor doesn't receive any infrared radiations, it means automatically vice versa. It is on the black surface or black line. Arduino Mega. The Arduino Mega 2560 is a microcontroller that we are using to program our robot. It behaves as the brain of the robot, the main controller of the robot. It tells the robot that what to do and how to do, basically. Now Arduino Mega has a lot of input and output pins, so it means that we can take a lot of data as our input and output at the same time. Arduino Mega has more sketch memory and more RAM as compared to Arduino Uno. It has more baud rate, and baud rate means the data that is being sent and received by the microcontroller with respect to some time. It has 54 digital output and input pins, 16 analog pins. This microcontroller, it has, I think, 6 timers. This microcontroller is used for the complex projects and it is very helpful. Features: it is an 8-bit microcontroller, it has high performance and low power, it is used in advanced RISC architecture, it has high endurance non-volatile memory segments. In system programming by on-chip boot program, true read while write program. Different functions. There is our mini USB that we can connect, a fuse for USB protection, regulator of 5 volt, external power supply, regulator of 3.3 voltage at Mega 16 U2 microcontroller, USB driver, power pins, analog input pins, reset button, digital inputs, outputs, PWM output, and serial communication pins, the USART pins or UART pins, whatever. Motor driver L298. The motor driver L298 is used to derive drive the motor. By giving them the voltage, the motor driver operates on high voltage 12 volts and on high current. It is one of the building block of the line following robot. If there is no motor driver, then certainly there is no way to drive the motors perfectly and efficiently. Basically, the main function of the L298 motor driver or the H bridge is to synchronize the motors, that the motor runs at the same time. If suppose the direction that it follows, our robot is straight, so it synchronizes the motors and they are being able to move at the same time. So you can see the robot stays still in the straight direction and does not fumbles, and this is the basic purpose of our motor driver, so that it can follow its path perfectly without I cannot say that quite perfectly, you can say. It has dual full bridge driver, which is specifically designed to accept the standard transistor to transistor logic and drive motors of our robot. The two enable pins are provided to enable the motors on our will or to disable it. By connecting the lower transistor emitters of the bridge, the external terminal of motor driver can be used of sensing the external resistor. This is the picture of L298 motor driver. It is a module. Working principle of the motor driver L298 is it can be used to operate two output power stages. The stage of the motor driver which is used to operate any kind of load or motor. In our case, this configuration is known as bridge configuration and can operate the motors in differential or in common mode depending on the inputs of the state. The sensors that the output that is flowing through the bridge and an external resistor allows it to detect the amount of the current that is flowing. Speed control of the motor. Controlling the speed of the robot is the utmost demand. It is the basic demand that every engineer I think demands. Motor speeds can be controlled directly by the controller by generating PWM in the signals that we are giving input to the motor driver, or we can control speed by giving PWM to the PWM pins of the motor driver. We tried to use PWM but our robot wasn't working properly, so we just used the direct speed control. That means we used direct DC voltage was given to our motor driver. Working of robot. The line following robot basically uses IR sensors to sense the path and give signals to our microcontroller, and then through our logic its output signals are given to motor driver, that is L298, and then it drives the motor either in forward direction, reverse direction, stop, left, right, depending upon signals given to it. In the figure you can see the block diagram. The analog signals are given and then the binary data is going inside. This is our input system, this is our processing system, this is our output system. Binary data is being given to our logic circuit that we programmed using different softwares, and motor driver once L293D or L298 straight movement. For that, when the given conditions comes, our robot moves forward. That S1 if S1 is equal to 0 and S2 is equal to 0 and S3 is equal to 0 and S4 is equal to 0, S5 is equal to 0 and S6 is equal to 0. Basically the S1, S2, S3, S4, S5, S6 are our IR sensors. That means if they are all equal to 0, then our robot will move forward. Else if S1 is 0, S2 is 0, S3 is 1, S4 is 1, S5 is 0 and S6 is 0, then the condition remains true for the forward direction, And if s1 is equal to 0, s2 is equal to 1, s3 is equal to 1, s4 is equal to 1, s5 is equal to 1, and s6 is equal to 0, means the four sensors in between the extreme left and extreme right are 1. That means the condition of forward direction is followed by our robot. Right movement, for our right movement, s1 is equal to, if s1 is equal to 0, IR sensor 1, IR sensor 1 is 0, IR sensor 2 is 1, 3 is 1, 4 is 1, 5 is 0, and 6 is 0. Then the right motor, the robot will move towards right. The second is that if IR sensor 1 is 0, IR sensor 2 is 1, 3 is 0, 4 is 0, 5 is 0, 6 is 0, then the condition remains true for the right movement of our robot. And furtherly, these are the conditions for the right movement. And in case of left movement, I will tell you about that if s1 is equal to 0, s2 is equal to 0, and the three next sensors s3, s4, and s5 IR sensors give the are equal to 1, then, and s6 is equal to 0, then the robot moves left. Now this is our software design. Here you can see that this is our Arduino Mega, and these are the components that were attached towards inside the PCB that we made. This is our Arduino Mega, and all the pins that I have discussed earlier are attached. So the analog pins here are attached, some analog pins, some PWM pins, and all of that. And first of all, here we can see these are our current sensors that work on the Hall effect mechanism. That means if we increase the load on it, and it will convert it into electromagnetic waves, and it will produce a current. It will induce a current in it, and it will be measured by the current sensor. These are our VCC, EC2 pin, VCC, EC1, ground EC2, ground EC1, IR ground, and IR VCC of our IR sensor pins. Then here we will see that this is basically for the IR sensors. These are little pins that most left, center right, right, and most right. And then these connectors are used for the LCD and for our LCD and the potentiometer that we will use. So these are here we can see that the data pins D4 up to D7 are connected here, and furtherly the pins up from D1, the data pins up from D1 to D0 to D3 will not be used, they are grounded. Enable pin is connected and the RS pin is connected. RW has been ground, and a voltage VDD is given as VDD of the LCD is given. Here we can see VDD gives our input, VEE is attached to our output, and VSS is ground. Then we will come up to the pins of the motor driver. These are the pins of the motor driver. The input pins as input 1 and input 2, that and input 3 and input 4 of the and enable B and enable A in order to control the RPM of the motors. And these are the inputs given to the motor drivers from the Arduino pins or the IR sensors. Ultrasonic is also used to detect the possible obstacle that comes in our path. There are 4 pins that the first one is of VCC. About 3.3 up to 5 volt VCC should be given to this ultrasonic sensor. Ground is our 4th pin, and 2 and 3 pins are our trigger pin and echo pin. Echo pin is basically our receiver pin. And SD card module, as I told you earlier, that there are 4 main pins inside that VCC is given at 2nd, ground at 1, MISO, MOSI, SCK and CS. These are the 4 main pins of the SD card module. And you can see all of these are attached to the pins of our Arduino ATMEGA2560 towards different ports and pins. Inside pins of the different ports. And now we will come up to our PCB layout. So this was our PCB layout, and here we can see that our 6 IR sensors are attached about most left. This is basically our QTR sensor that gives us the most left side, center left, center right side and most right. And IR, basically the VCC pin of our IR, ground pin of our IR and all these. Then the pins of our motor driver and enables for the RPMs of the motors. Furtherly, the SD card module that we use, the pins are attached towards the Arduino, and for LCD the connectors are used. Instead of using the whole module, you can simply use the connectors and assign them their pin and connect them to the Arduino. And the voltage sensor and current sensor are also used. Voltage sensor, current sensor and all these things. So furtherly, I've explained the components inside the video. You can see, and you will see them that as follows. And then the line follower, the actual robot, that it follows a black line over a white surface. Assalamu alaikum. So this is our video for the components that we used in our line following project. And first of all, you can see there is a big Arduino 2560, blue colored and the rectangular shaped, and there are some connecting wires which are connected through our voltage sensor. So the function of the voltage sensor, it works on the function of voltage divider. Basically, internally connected 2 resistors are used inside it, one of 75k ohm and second is of 30k ohm. And there is a 16x2 alphanumeric LCD that is used to show the value of voltage and current using the voltage and current sensors and display on it. And current sensor, the one with the green header you can see. So it works on the Hall effect mechanism, and then comes our motor driver, inside which the input is being given by the IR sensor. At the left of the PCB you can see that this is our QTR sensor. It is a strip in which 5 or 6 IR sensors are connected, and SD card module for the it is the basic function of our SD card module is to store the distance or the path that is being followed by our robot. And above the SD card module, at the right top, a potentiometer is used to decrease or increase the brightness or intensity of our LCD. On the top of that there is our Arduino connecting cable, and inside, and I was talking about motor driver. So inside motor driver there are pins that are connected in which the input pins are connected towards our IR sensors, and output is being given to the servo motors, and we have all placed that inside our PCB. So here you can see, and furtherly we will see that how this robot moves, and 4 wheels will be applied, and there are 2 encoders that basically tells us about how much revolution is being given, and SD card module from that gives us the path followed or the